Hi again, and welcome back to the second part of the analysis breakdown for 2.9 investigations inference. And today we're looking at the second part of CSSI, so skew and spread, shape and skew, and interesting. So for the shape, we're looking at the skew or the symmetry of the box and whisker graph. So you can see in these pictures that this one here has quite a long tail on this side, the right-hand side, so we call it right skewed. It means there's a few values in our dot plot that are away from the rest of the values. This one is left skewed because the tail is on the left-hand side. This one we call symmetric because it looks all nice and even. We have lots of ways we can describe the shape of the graph. So one of these is to use these sort of words. So something that looks normally distributed, if you don't know what that is, you could just say it's symmetric, or a triangular symmetric, rectangular, or an irregular graph. Or we could have a bimodal graph. That means there's two peaks in the graph. Or multimodal. These asymmetric ones, where they're skewed on one side, just remember that the skew goes to the tail. So the tail is on the right, it's skewed to the right. So we're looking for evidence that it's skewed where the tail of the dot plot is. We can look at the box and whisker to help us out there. A numerical measure of skew is how different the mean and the median are. If the mean is pulled away from the median in the direction of the skew, we can compare these distances between the quartiles on either side as well. For example, I notice that the amount spent at the formal by boys is skewed to the right, and the amount spent at the formal by girls is also skewed to the right. My evidence is that the mean amount spent by boys and girls is greater than their median amount. So for boys, it's $204.70, which is greater than $185, and for girls, $408.40, which is greater than $295. This means that there are some girls and boys that spend a lot more than the majority of the group. So this sort of idea is really important when you're discussing the shape and the skew. We could say that they are symmetrical. We could say they're bimodal. All those comments can come into this part. When we're talking about interesting features, we're looking for something that makes the graph a little bit different. So we might be looking for groupings in the data, like this particular one. We might be looking for the fact that the data has two peaks. And this is only a minor peak, but there's definitely a two thing going on in this particular diagram. We could be looking for an outlier, which is a value that is believable, but is way on the outside of the data set, and we would talk about that. You can use NCEA to colour the data, so you could look for groupings that are associated with different things by doing that as well. So it might be that these two groups are male and female, or they might be different products, or those sort of things. So it's important to actually look for those things in your data set and talk about them. So we've got here the weight of hatchbacks, right? So we could talk the interesting here with this dot way down here, or these ones way up here, the bulk of the data being in here. All right, this looks like it could be two groupings as well. These are the sort of things you can talk about. I noticed that the weight of hatchbacks in my sample are bimodally distributed. This appears in the irregular shape, so bimodal, one here and one here. My evidence is there are two peaks centered around 1,450 kgs and 1,850 kgs for the station wagons, and the weights varied greatly. There may be two types of hatchbacks, a smaller one and a larger type. I would need a larger sample to be sure that this bimodal pattern was also in the population. All right, so making sure that you're quite specific about what you're telling them. If a dot plot is very clearly bimodal, then this is worth discussing. If it's not clear, then just watch out. One definition of an outlier can be to multiply the interquartile range by 1.5. But we don't need to do this. If we can see that it's an outlier, we can state that it's an outlier. So if it's a long way away from the rest of the data, but it's a believable value, we can make comment about it being believable, but we don't. The way we deal with our data means that the outliers don't become that important. All right, so your turn to have a look at the marathon data and see if you can write these two parts of your analysis. Good luck.